Hello, my fellow weather enthusiasts. Today I'm going to show you how to view weather model data. The site that I use is pivotalweather.com. Once you go to the website, it may look something like this. You'll want to go to the Models tab and go over here to where it says Animation and hit Forecast Loop. From there, you'll have the model data right here. Of course, there's several different global models. These are your medium range models. Um, there is a long range model right there, the CFS, the European model, the American model, the Canadian model. And then you have some short term models here, the NAM, the RAP, and the Canadian short range model. And then you have very near term models like the HRR or Triple R, the NAM 3K, and some severe weather parameters, the HRW. And then you have some ensembles, which basically kind of takes like different parameters of the GFS. There's tons of different ensembles and kind of packs them into one model. So it kind of gives you a range of different outlooks, solutions. So we'll just start with the GFS. So it's kind of like the most popular. Um, you'll notice in the top left here it has run. That just kind of means the latest like run of the data. So for instance, this model was ran Thursday 12/9 at OOZ. So there's different like time frames. I would say like it's almost like military time. So this is just the most recent. It's always going to be at the top. Um, and as you can see, this model does not. So like this is like the time frames. So like 6 hours out, 9 hours out, 12 hours out, etc. So you'll notice it kind of stops here. That's because the data is still being ran. So if you notice here, this is not fully complete. So this is the freshest data. It's just not fully ran all the way yet. So give it some time and it'll eventually fill up and then you'll have the full model run. So we'll want to look at the latest full run, which would be the Wednesday. And then that'll give you the full data there. So you'll want to go to the animation, hit forecast loop, and then this is going to be the full 384 hours of data. So down here under parameter, you have kind of like basically what you're going to see on the map. So in this instance, we're looking at precipitation type. So whether it's rain or snow, um, it's going to kind of show you what the data is suggesting. And like I said, it'll go up to 384 hours out. So I live in Northwest Tennessee, so kind of focused on that area. Looking pretty quiet there for mid-February. Also the dates and then the time is going to be right here. So you'll kind of notice once this gets to around 24-hour mark, it'll change to the next day. So February the 14th, and then you'll notice it'll change to the 15th. This is showing around noon on the 15th. So you can just kind of do it in section there, or you can actually play the whole loop. I just kind of like to drag it. So looking pretty quiet around my region. So that's kind of what the GFS model was thinking is going to happen for the next few days. And then we have different model data. So European model. And you can kind of see there's variance between every model. So every model is going to have kind of a different solution. So it looks like this model shows a little bit of snow possible coming up over the weekend here. Another thing you can do is go right here to where it says zoom, and then go by regional, United States, and I am in the Ohio Valley region. So that'll kind of give you a close-up view of your area. So like I said, looks like we got some snow coming up. It may just be rain. Have to keep an eye on that one. And then we can go to the long-range data, the CFS model. And this one defaults back to the continental United States. I don't think you can get a close-up zoom. Every model has different parameters. You may not be able to see like precip type. And then we'll kind of go through some of the other parameters. But this one is the longest range model. It'll go out 768 hours. So you can kind of see the long range data, which generally is not very accurate. But it kind of gives you an idea to look for trends in the data to see, you know, if it's going to be cold and kind of check the data. I believe this model runs twice a day. So you look for trends and to see kind of a general idea of what's going to happen long range. And like I said, it will flip-flop from day to day, but you'll kind of see consistency, you know, as it gets closer to the time. So another thing I like to look at on the long range, other than the precip type, would be the temperatures. So this is going to be like your upper air dynamics, height, wind, temperature. You have the anomalies from average. So on that one, I like to look at the temps. Oh, I'm sorry, surface. So this is up in the upper atmosphere. So we want to go to the surface. So the surface will be right here under surface and precipitation, obviously. All right, so you can kind of look at the data there, see kind of what we're looking at long range. Looks like we're kind of in between 60s and 40s in northwest Tennessee. So that just kind of gives you a rundown on that. And we can go here to the short range models. These will give you a better resolution, kind of like on precip coverage type, and probably a lot more accurate actually, and what would probably happen, you know. So higher resolution basically, but it doesn't go out as far as like how far it runs in time frame. Another product I like to look at is under the winter weather. You have your snowfall products, the 10-to-1 ratio. That kind of just takes in, most snowfall we have is 10-to-1, but you have the Kuchera ratio, which will take into account the temperatures. So if it's extremely cold air mass, we may have 15-to-1 ratios, which would be 15 inches of snow to 1 inch of rain. So we can kind of play around with that data and see what the model thinks as far as total precipitation, snow accumulation. And then we have the convection allowing models. So this is good for like severe weather. It has a parameter there for that. One of the things I always like to look at is the tornado parameters. And this just kind of gives you an idea of any potential severe weather outbreaks. Looking pretty good for my neck of the woods here. Maybe Thursday looks like some parameters show a little bit of severe weather, so you can go into other parameters like the CAPE, like the energy the storms have, the fuel to fire up. So we do see a little bit on Thursday, and let's kind of see what the radar would look like on Thursday. Yeah, we may have some storms. Nothing too crazy, but something to kind of watch Thursday. Then you have your ensembles. This is a National Weather Service ensemble, I believe, and this just kind of takes several models and kind of bundles them all up into one, and I'll give you a really accurate model run. This is just a total snowfall. Looks like we might get a little bit. But anyways, that's kind of the basic things that I look at when looking at long range and short range models. It's really fun to just get in there and play around with it. Um, it has all kinds of parameters, and it's just really interesting to look at what like forecasters look at. Like, you know, you might have different forecasters saying different things, and you can kind of look at the data and see if you agree with like maybe what's going to happen. And it's just interesting, if you're looking at a weather app and 10 days out it shows different solutions, and you kind of want to look at what could else happen, what else could be on the table. It's just a neat thing to look at, and the more you use it, the more familiar you get with it, and you can kind of predict your own weather. And that's it for today.